Welcome to the fifth video of Module 4 on logarithms, where we're going to look at more application problems involving pH. In your science courses, you've learned that atoms and molecules contain protons and electrons. However, when an atom or molecule is positively charged or negatively charged, it's referred to as an ion. An electrolyte is a substance that forms ions. Ionization is when an electrically neutral atom or molecule is transformed into either positively or negatively charged atom molecule. Water is a typical solvent where ionization occurs. When a water molecule dissociates, it leads to the formation of two ions, the hydrogen ion, H+, and hydroxide ion, OH-. Notice that both of these have a charge. The concentration of hydrogen ions in any solution is directly related to the pH of the solution. A logarithmic equation is used to measure the acidity or alkalinity of the solution. The pH of the solution is dependent upon the molar hydrogen ion concentration of the solution, and the relationship between these two is that the pH is equal to the negative log of H+, where H+ is the molar hydrogen ion concentration in the solution. In the following application problems, we'll use this formula to answer various questions about pH and H+. Example 1. For a pH of 4, what would the H+ molar concentration be? So given our formula, we can substitute 4 in for the pH. So 4 is equal to the negative log of H+. And what we want to solve for is the variable H+. The first step to solve this equation for H+ is divide both sides of the equation by -1. We get that -4 is equal to log of H+. Remember that this logarithm is the common logarithm of base 10. Now writing this equation in exponential form, we find that H+ is equal to 10 to the power of -4, or 0.0001. Be sure to record your units as well, capital M here, for molar. Therefore, given a pH of 4, the H+ molar concentration would be 0.0001. In example 2, we have if the hydrogen ion concentration of human blood is 3.0 times 10 to the -7 molar, what is the pH of human blood? Recall that pH is equal to negative log of H+. We are given that H+ is equal to 3.0 times 10 to the -7 molar. Now substituting that into the equation, we get negative log of 3.0 times 10 to the -7. If we evaluate this in our calculator, we get 6.52. Now we've looked at using the formula that relates pH to the molar hydrogen ion concentration and looked at substituting either of the two unknowns to solve for the other. A way to go, and now we're going to move on to some examples. So pause your video and practice the following examples, then refer to the solutions. Find the pH of a detergent with hydrogen ion concentration of 9.91 times 10 to the -10 molar. We can calculate the pH now is equal to negative log of our concentration. Evaluating this in our calculator, we get that it is equal to 9.00. I should say approximately 9.00. I've decided to round to 3 significant figures since our concentration was given to 3 sig figs. In question 2, it says, what is the H+ concentration for a pH of 9? So we know that 9 is equal to negative log of H+. Now divide both sides of the equation by -1 to get the logarithm by itself. We get that -9 is equal to positive log of H+. Now re-express this equation in exponential form. We find that H+ is equal to 10 to the -9, which can be written as 1.0 times 10 to the -9 molar. Question 3 says the gastric juices of the stomach must have a pH of exactly 2 in order for pepsinogen to be converted into an active enzyme pepsin. Part A asks us, suppose that the H plus of the gastric juice is 0.02. Will pepsin be produced? So now we need to calculate what the pH is given an H plus concentration of 0.02. We will compare that value to the required value of pH of 2 to determine whether or not pepsin will be produced. So we find pH is equal to negative log of 0.02, which is equal to 1.70. We know that 1.7 is less than 2, therefore pepsin will not be produced. In a follow-up question, part B says, now suppose that the H plus of the gastric juice is 0.05. Will pepsin be produced now? Calculating the pH for an H plus of 0.05, we find that it is equal to 1.3, which is still less than 2. Therefore, even though we've increased the concentration from 0.02 up to 0.05, we still see that pepsin will not be produced. So in part C, it says, what do you notice about the pH in the above examples? How does the H plus affect the pH? Looking at these two examples, we see that as the hydrogen ion concentration increases, the pH, in fact, decreased. Therefore, there's an inverse relationship between these two variables. Question 4 says, a urine sample is taken from 2 different patients in the hospital. The urine for patient 1 has a pH of 4.7, and the urine for patient 2 has a pH of 6.7. It says, note the pH of urine, of normal urine, runs between 4.6 and 8.0. Therefore, the pH of the urine for each of the patients is within the normal range, so 4.7 and 6.7 both fall within the acceptable range of 4.6 to 8.0. Question A says, which patient has the more acidic urine and how can you tell? In the last question, we identified that if H plus concentration goes up, then our pH goes down. In this case, we have patient 1 who has a lower pH. That means that their H plus concentration is greater. Therefore, if the hydrogen ion concentration is greater, their urine is more acidic. Therefore, patient 1 has more acidic urine. Part B says, how much more acidic is this urine compared to the other? Let's investigate the difference in their pH. We know the difference is equal to 6.7 minus 4.7, which is 2 full units of pH. We know for each decrease in pH by 1 pH unit means a 10-fold increase in the concentration of hydrogen ions. So we can express this difference as 10 to the power of 2, which is equal to 100, and therefore the acidity is 100 times greater. Part C says, why might this patient have more acidic urine, and what factors may lead to more acidic urine? This is a great question to explore in more detail in your biology class. So your answers may vary here, but you may consider ideas such as diabetes, starvation, and dehydration. In the last question in this module, we'll look at another gastric juices of the stomach problem. So the gastric juices of the stomach have a pH of 2 in order for pepsinogen to be converted to the active enzyme pepsin. So if the H plus of the gastric juice is 0.01, will pepsin be produced? We want to calculate the pH. For an H plus of 0.01, we get minus of negative 2, which ends up being positive 2. The pH we found here is equal to 2, therefore we know that pepsin will be produced. Part B says the enzyme lipase has an optimal pH of 7.2. What H plus concentration must be present in the small intestine to maintain this pH? What we are looking for is the H plus concentration, which corresponds to a pH of 7.2. Substituting 7.2 into our equation, we get the 7.2 is equal to negative log of the H plus, dividing both sides by negative 1, And re-expressing this equation in exponential form, we get, so H plus is equal to 10 to the power of negative 7.2. We can express this to two significant figures as 6.3 times 10 to the negative 8. Part C says a urine sample has an H plus of 0.000000001, which is equivalent to 10 to the power of negative 9. And it says, is the pH of the sample in the normal range for urine? Recall that the normal pH for urine is between 4.6 and 8.0. So let's calculate the pH for this hydrogen ion concentration. We find that it has a pH of 9. Therefore, this sample is not in the normal range for urine. Okay, great job. Now we've looked at many application problems of pH and the hydrogen ion concentration. Make sure that you give these questions a try on your own and reach out for help if you need anything.